in order to get this benefit of multi-cloud and adopt a platform like an OpenShift or an Anthos, do you have to buy into one of the vendors to enable that, or can you do it without using a vendor?
Yeah, so the idea of a multi-cloud essentially stems from the fact that you're using some public cloud service, and just by the virtue of calling it public cloud service, you are signing up to one of the big providers of this service. So therein, you are using some vendor's service. Obviously, what you run in that vendor service could be completely your choice, which is where the work that we have done, obviously in the open source world, plays a huge role, because there are components of cloud native aspect, which essentially is many of the people within the community that they've developed. But all of this needs to run somewhere, and you are locking in yourself to some cloud provider to provide that. You can, like we talked about, build your own infrastructure and call it your private cloud, adopt the principles of the private cloud principles, run it in a way you want it. You're not locked into anything, but you're locked in somewhere in some fashion, either to the infrastructure. Either you're locked into the infrastructure that you're managing, or you're locked into the vendor that is providing a service. In some ways, you are using somebody's services, right?
So you're saying that vendor lock-in to some extent is always inevitable.
So that is where the aspect of multi-cloud helps you manage that a little bit. So the idea is that you're not locking yourself to a single cloud provider where essentially you are either all in or out. So the multi-cloud helps you sort of manage that risk by spreading out your services, where you're not locking yourself, but you're still consuming vendor services, but not necessarily locking yourself to a specific cloud provider.
So does that mean that if you go into one of these solutions that enable multi-cloud, you could actually move your services out of that into another one?
That is the idea of, well, most of the organizations adopt that multi-cloud strategy with the idea that, if something were to happen in the future, that there is a change in relationship or something, we should be able to easily move out all of our services from one cloud provider to the other cloud provider. And that goes back to the containerization strategy, that goes back to Kubernetes, because all of this is built with the basic building block of you deciding how you're going to manage your workloads. Since you've already chosen that you're going to containerize your applications, since you've already chosen that Kubernetes is going to be that operating system which will run my workloads, you have that flexibility to say, I'm going to move from a cluster that is operated by a provider to another cluster which is operated by another provider, because from my perspective, I'm just focused on developing applications and writing code. I have that flexibility to move from one provider to another provider easily.
So you mentioned mitigating risk a few times then. You've talked about regulatory requirements. I mean, as far as I'm aware, there is regulation in place that says if you have a certain percentage of your applications running in a certain environment, you have to spread that risk by moving it into other cloud environments. Yeah, you can't all have it in entirely one data center, for example. You've talked about the flexibility to move, the ability to take benefits of different cloud environments. That's all well and good. Are there reasons why you wouldn't want to go multi-cloud? I mean, it does sound like it might be expensive, for example. Like, who would you be saying, oh, maybe you shouldn't actually consider a multi-cloud strategy? Does that exist?
You've rightly pointed out cost. I mean, it doesn't come cheap. So if you are adopting a multi-cloud strategy, you are essentially managing, you are willing to invest effort, time, cost, all of the things to have that expertise across multiple different cloud providers. It's not just about saying, I'll have one person who's an expert of everything. We all know that, it doesn't happen, even though there may be some people who are experts of everything, but very often you will have to staff people accordingly to help manage that, various different cloud providers and the resources that are running in those, and the expertise. The most important thing, which I haven't talked about, security. All of those plays a huge role in this. But that said, there are organizations, and you've known a few, I've known few, who have all in on a single cloud provider. And that is part of a strategy for some organizations, where they probably have some kind of a partnership, some relationship where they say, we are going to go all in on a single cloud provider, because that is our strategy. And it all goes down to the the building blocks of what your journey going to look like from a transformation perspective, and what you're willing to do for that transformation. And if you're willing to bet everything on a single provider, that's perfectly fine. We have a lot of customers that are on a single cloud provider, but we also have many customers who are across all providers as well.
It doesn't really matter then whether you're a certain size of organization, or it's all just down to the specific requirements of your business. That's kind of what you're saying?
Yep, it is the business that drives it. Absolutely.
Coming on to specifically onto Kubernetes then, and how Kubernetes can help you to sort of provide multi-cloud environments. How do you think of architecting Kubernetes in a way that's going to make the most of these multiple environments, and how does multi-cluster then play into that?
Yeah, so multi-cluster is essentially a strategy. I mean, obviously you can think of multi-cluster strategy in two different ways. Some operate in an active mode, in which they say all the workloads that are deployed are spread across multiple clusters, essentially in a way to make sure that no service is down at any given point of time. They're always available. Say the classic idea of something running active. One part of it goes down, the other part continues to run. Purely from a Kubernetes architectural perspective itself, there are a couple of things obviously to consider. One, where you want to run your Kubernetes on, whether it's a managed Kubernetes offering or whether you're going to build your own clusters. So that goes into one of the decisions that is initially made. The second piece also is from an architectural perspective, it's less about how it has to do with how you architect Kubernetes, but it also has more to do with what is your strategy for getting that application that you're building into Kubernetes. Because from a Kubernetes perspective, you give it a YAML, it'll deploy it happily. Is this YAML that you're going to give it, every month, every 6 months, every quarter? Or is it something that you want to design to be able to say, every time there is a change, we want an automated process that completely tests it, completely evaluates it, moves it from development to staging to production, all of it with a single click. That's where we've seen the likes of, the GitHubs or, Flux or Argo, all of them playing a huge role. It's more of an ecosystem of things that work with Kubernetes that makes the strategy from an architectural perspective. And it's not just Kubernetes, right? Because Kubernetes, like I said, I already described it as an operating system for cloud native. But you don't just use the operating system, you enhance your operating system in a way where it works for your business. And one of the projects that we all know very well, Cert Manager plays a huge role in that from a security perspective. It's not just about running applications. The next question would be, how do you secure it? Where do I get the identities for it? How do I manage the identities? How do I scale those identities as the applications scale as well? So all of it is essentially the architectural piece that's sort of you can almost look at it as the ecosystem around Kubernetes that makes it much more valuable from an architecture perspective. Kubernetes, the pieces that all plug into Kubernetes in the form of your pipelines that feed into Kubernetes, the applications, the security controllers that essentially help you secure it, the vulnerability scanners that are continuously checking your images. All of this essentially play a huge role in the architectural picture that represents how you are adopting a cloud native strategy. And this, obviously, you run across multiple clusters because you want to make sure you are running it across multiple clusters to help scale and make sure that they are available always. Multi-cloud obviously fits in depending on where your Kubernetes platform itself is running. You could be running on AWS, you could be running on Google Cloud. All of them offer their managed Kubernetes offering. You could be running it in OpenShift, which is very common from the perspective of how we look at it. In practice, however, when we talk to customers, and I'm pretty sure you have a lot of experience as well, you have a Google team that's doing things in a certain way. There's an OpenShift team that's doing it in a certain way. There's an AWS team doing things in a certain way. Although we all are talking about a consistent mechanism through which you want to operate, architect, and run in reality, many times it also comes down to the various teams that are managing the platform themselves and how they have architected it and how they have run it. Some use, for example, continue to use Jenkins, and some use Argo, and some use GitOps with Flux, and it's a choice. And I think that's important because the idea of cloud native, the idea of being operating Kubernetes provides you that choice that helps you manage in a way with the tools and the technologies that you are most comfortable using it, as opposed to saying there is only one way that it works and this is the only one way to do it. There is no such thing. So every developer, every platform team have a choice, and they can use that choice to help scale and architect this in a way where it works best.
That choice obviously is great to have, especially if there are consistent technologies that underlie it, because then that gives you consistency across these multiple different environments, I assume. But if you're saying there are different flavors and different teams adopting the technology and using slightly different flavors, surely there's going to be differences in that. And does that not cause organizational issues in how to apply consistent policies and controls and so on and so forth? And then when you have like multi-clouds, I'm assuming there are slight nuances in how you would run those services or that Kubernetes environment within that cloud, because some people might just assume, oh, all clouds are the same, but they're so complex now, and they offer so many different services. There must be differences in how that happens. Could you not end up just with this one big mess of technology at some point?
Yeah. So you're in the right track on that question, right? So because there are many teams, as we know, every team operates Kubernetes in their own way. Every team operates and runs their cloud environment in a certain way. Where does that leave the enterprise? Where does that leave the enterprise governance? Where does that leave the enterprise policy controls? Because from an organization's perspective, there is still somebody who's looking at how do we as an organization operate. It's never about, it's definitely about how each of the teams operate, but they all have to aggregate up to somebody looking at it from an enterprise perspective. Most of the conversations that I have with customers has to do with what does that enterprise security posture look like from the perspective of Kubernetes that you're operating, from a security perspective, the kind of identities that are used, how does it look like from the perspective of applications, pipelines that are deployed. So all of that from an enterprise level is extremely important. So there is value that enterprises get, obviously, from using certain products or certain other products that sort of ties in all of these together and provides an overarching enterprise value to say we have X number of clusters spread across these many cloud providers, and this is how they are operating at this time. This is the health of each one of them. This is the security posture of each one of these clusters. This is how this is where there is a drift in configuration, because one of the configurations that are applied to a certain cluster within a certain cloud environment is not consistent with the other cluster that's operating in the other cloud environment. How do you know about all those things? If you're operating in silos, you'll never know about it. So there is something that is absolutely needed, specifically from a security perspective, to help drive that value for organizations.
And what is that?
Oh, yeah, of course. I was waiting for you to ask that question. Right? I mean, from a machine identity management perspective, as you know, we want to ensure that every single workload that's out there is secured and has a cryptographically signed identity. I mean, that is what we do. That is what we drive for. That is what we enabled a while ago, even when Kubernetes started, and you've been in the forefront of it, driving that project called Cert Manager to help manage those identities within Kubernetes clusters. And that has its own sort of has taken over essentially how identities themselves are managed within every single cluster. And it's not just about that entry point, so to speak, right? It's also about how every single workload is secured. When people containerize applications and deploy it, we're not talking about one container or two containers or 3 or 10. We're talking about thousands of containers that are deployed and running this in clusters. So to be able to think about the scale at which each one of these talk to each other, like for example, service A talks to B, B talks to C, C talks to E, you essentially have a mesh of services that are talking to each other. So all of these need to be secured. All of these need to have an identity. And if from a security perspective, especially if you're driving that architecture around zero trust, you want to ensure that from the time of the origin of a request from a browser to the request completely handled by some pod within a cluster that's operating in one cloud provider or the other cloud provider, that entire chain needs to be secure. That entire chain needs to be cryptographically verifiable, identified. And from that perspective, that is one thing to be doing. On the outside, when you operate this across multiple different clusters, there needs to be a view of what is happening. There needs to be a posture of, that organizations can build. And that's what we've been doing at, obviously, Venafi and Jetstack to help drive that enterprise security posture for organizations to understand how workloads are secured, how workloads are signed, how workloads are governed using the infrastructure that you potentially have in place already, and use the combination of obviously the Venafi and Jetstack products to drive that value for them. So it is possible, obviously, it is there. Many of our organizations use that, but the complexity, as we talked about, is huge and big. And adoption of cloud native strategy and thinking about containerizing makes these workloads massive in number, gives the idea that all of these workloads are many a times highly ephemeral. So we are talking about workloads that somebody deploys 10 times a day because they just change a line of code, and they have process in place where it will automatically deploy, which means everything sort of goes through a cycle of tear down and destroyed, and it gets built again, which means the associated identities also need to be managed in the exact same way. So we tie in the life of an identity to the life of the workload itself, so that when a workload is born, we stamp an identity. When a workload dies, we take away that identity. It's not needed anymore. So just by the virtue of a workload being born in an environment somewhere, we have the ability to inject an identity to it automatically.